Here we go. 1, 5. I'm also recording, so please keep your profanities to yourself. All right, 1, 5. Here we go. Translating, yeah, that's on the video. Translating with inequalities and inequalities. All right, we're going to do some solving inequalities today. So we've already solved equations. Solving inequalities is a little bit harder, but it's pretty much the same idea. We're still trying to find out what x can be. All right, so solving inequalities. Let's start with just a little introduction into what inequalities look like, how we're going to do the problem, stuff like that. So we're going to have a little chart again, and we're going to have a word sentence, and then we're going to have an inequality in math symbols, an inequality, and we're also going to add a graph. Now, it's not the kind of graph that you groan about whenever I say, oh, graph this. Don't you hate graphing? And everyone's like, ugh. It's just a graph on a number line. It's pretty quick and easy. It's just one variable, just x, not x and y. All right, so this says word sentence. That's an E right there. Word sentence. So let's start with something pretty basic. And let's say that x is, right there, greater than 4. Okay, that's a word sentence. It has words in it, actually has a variable, but x is greater than 4. So what we're going to do is we're going to translate that into its mathematical inequality. So x, that's our variable we're going to use. We change it up a little bit, but most of the time we use x, is greater than. So we're going to use the greater than symbol. Remember that little guy? Did you learn it as like an alligator or a cookie monster or something? I don't know. X is greater than the number 4. And there's an infinite amount of numbers greater than 4. If I asked you, pick a number that's greater than 4, okay? You could say 10 or 14 or 100 or 1,000, 20,000. So we're going to graph this on a number line. I'm going to put 0 right here. I'm going to count 1, 2, 3, 4. And I got to represent all the numbers bigger than 4. Now, some people will start at 5 and go from there. But that's not right. Because then you're leaving out all those decimals, right, and fractions between 4 and 5. So the way we represent it, I don't know if you remember, you put an open circle on 4, and then you push all the way that way with your arrow, saying all the numbers greater than 4, but not equal to 4. That's why the open circle's there. Do you guys recall that from Algebra 1? Yeah? Okay, good. Okay, so let's do this one then. How about, let's do a different variable. Let's say m. M is less than or equal to. M is less than or equal to 3. M is less than or equal to 3. Hope your writing's nicer than mine. All right, so here we go. So let's pick m is our variable here. And now we're less than or equal to. So away from the m. And then what do you do for or equal to? Yes, an underline, a little bar there. So m is less than or equal to 3. Perfect. Do you remember this? Yeah. All right, so then you go to your number line. Usually most people put 0 in the middle. You don't have to. It doesn't matter. 1, 2, 3. And this time, to represent m is less than or equal to 3, I'm going to include 3 in my answer by making it a solid dot. And it's all the numbers less than. Now, if your variable is first in this sentence, like you have x, you have m, then the inequality will tell you which way to shade. Did you ever see that? So x is greater than, see this arrow right here? It's telling you to shade that way. And if it's this way, it's telling you to shade that way. People kind of like that. Some people like, just do it. It's pretty easy. All right, now I have 2 more. These ones are complicated. So those are very basic, easy. How about if I said x is greater than 5 and less than or equal to 12. Okay, I'll say that again. X is greater than 5 and less than or equal to 12. So think of a number that's bigger than 5, but also less than or equal to 12. So here's how you want to represent this. You can do it two ways. Usually people will just put X in the middle and they'll write it as one whole thing. Okay, they'll say that 5 is less than X, but X is less than or equal to 12. Okay. If you don't like that, that's okay. You can split it up and you can say that X is greater than 5 and X is less than or equal to 12. You can write it out as words, or you could put it in one symbol, okay? And then let's go ahead and graph that one. That one's a little trickier to graph. So I'm thinking of numbers that are bigger than 5. So here's 5, and here's 12. I don't care about 0. So numbers that are bigger than 5, so that would be an open circle at 5. And going bigger than that way. But you see and means both have to be true. Okay? So then the numbers are also less than or equal to 12. So that would be going this way. So what you want to do is you want to just include the overlap of them. And think about it. Aren't all these numbers in here, all of them bigger than 5 and also less than or equal to 12? Yeah, they are. So it's all the stuff in between. That one was a little more tricky, huh? A little trickier. Okay, one more of these, and then we'll move on to the next thing. How about, let's say P. P is less than, almost looks like this. P is less than -5 or greater than 1. P is less than -5 or greater than 1. Now, if you have an or statement, ands you can combine because it's this and this, you can write it in one sentence. Ors you need to separate all the time. They have to be separate. So we're going to write two things. P is less than -5 or P is greater than 1. And that's how that would be translated from English into mathematics. P is less than -5 or P is greater than 1. And when you graph these or statements, they're going to go in opposite directions, okay? So we would go and put -5 over here, +1 over there. And we're going to graph pretty much two separate things, but on the same graph. So I say P is less than -5, open circle, pointing less than -5, that way. Or P is greater than 1. So if I tell you, hey guys, pick a number that's either less than -5 or greater than 1, there's going to be, people that go less than -5, and there's going to be people that decide to pick a number greater than 1, and you're all right, because it's an or statement. It's or, one or the other. Can you be both? No, that's not an and statement at all. Don't write it as both. Don't combine it. All right, let's do one more of these little things, and we're going to translate. You're pretty good at translating already. I just want to do one, or let's do two. Let's do translate. Letter A. Let's translate this. 5 fewer than a number same, I'm tired. 5 fewer than a number is at least 12. Five fewer than a number is at least 12. Okay, this combines the stuff that we did last week, the stuff that was on the quiz, but it also has our less than or equal to or greater than or equal to stuff. Okay, so let's start with the first part. 5 fewer than a number. How would you like to represent that? Anybody? 5 fewer than a number. Yeah, n minus 5. Perfect. N minus 5, x minus 5. So 5 fewer than a number. Okay, that's just the first part. Is at least 12. So this n minus 5 has to be at least 12. What does that mean? Greater than or equal to 12. Yes, greater than or equal to 12. If you have to be at least 13 to go to a PG-13 movie, then what does that mean? 13 or older, right? Yeah. So there you go. All right, try this one. Write this down and then do it by yourself on your paper. Here we go. The product of 10 and a number, the product of 10 and a number is no more than 50. Okay? The product of 10 and a number is no more than 50. Try that one. Try it on your paper. If you get it wrong, that's okay. Just scratch it out and we'll write the right one. But at least you're trying. The product of 10 and a number. I'm pretty sure you can get that part down. Product of 10 and a number, we'll call it 10x, 10n, whatever variable you want to use. Now here comes the new stuff, the kind of trickier stuff. What does it mean to be no more than 50? Less than or equal to 50. Good. No more than 50. Perfect. Are you bored to death? Don't answer that. Okay, here we go. Yes. Let's move on then. You got that? I don't want to insult your intelligence. You're doing great. Let's do some solving and graphing. Yay. Solve and graph. Okay, don't forget, when you're solving, you need to show some work. Okay? Write it down. Show your steps. You don't have to show them all. I know that you're in Algebra 2 now, and you're better than you were 2 years ago. So let's get right into it. Number 2. Solve and graph. Negative 3 times 2x minus 5 plus 1 is greater than or equal to 4. So we're going to solve that inequality. It's not an equation. There's no equals sign there. It's an inequality. And then we're going to graph it on a number line. There's a little tricky thing coming up. I don't know if you remember. I'm excited. Here we go. Someone said it. All right, let's go ahead and distribute. So you get negative 6x plus 15 plus 1 is greater than or equal to 4. Everything's the same way that when we did just equations. Okay, same idea. Get rid of the parentheses. Combine your like terms together. Negative 6x plus 16 is greater than or equal to 4. Subtract 16 to the other side. You know exactly what's happening. Negative 6x is greater than or equal to negative 12. Now here it comes. I don't know if you remember. I think you do. I see some smiles out there. Divide by negative 6, and whenever you divide by a negative number, what do? Flip the sign. You flip your gang sign up in the air. No, you flip the inequality sign. There it is. The gang signs. All right, there you go. So you flip it, and then you write it. Now, do you know that because someone just told you to do that every time? Or do you know that because you know why you do that? Ooh, that's a good question. All right. Let me tell you why that happens. Or just like not really. I'll show you. You know that 10 is greater than 5, right? Now, if I divide both sides of this by negative 1, or I multiply both sides by negative 1, what happens is I get that negative 10 is less than negative 5. The negatives work the other way, so you have to flip it the other way around. I don't know if anyone ever told you that or showed you that, but that would be the answer. Okay, so let's go back to this, and now we have to graph it. And in your homework, you're going to have to solve and graph. I will be looking to see if you did the graphs. Yeah?
Wait, on the last one, x is greater to or equal than 2. I think you flipped. Like before, it kissing is 6x.
Yes. And then I flipped it.
Yeah.
Yeah, because I'm dividing right here by a negative number. And anytime you divide by a negative or multiply it by a negative, you take the sign that's going that way and you flip it the other way.
Okay.
Yep. That's a rule. Don't forget that rule. Okay? All right, let's go over here. So we're going to go to 2. That looks like it's 2. And we're going to graph x is less than or equal to 2. And so fill that in and draw it to the left. Yay. I'm going to let you try one. Yeah, you're welcome. Number 3. This is easier, okay? A little easier. 2 times x plus 3 minus 1 is less than 8. I'm going to let you try this one. Distribute the 2x. We weren't talking about anything. All right, and then subtract 1, less than 8. Make sure that you combine your like terms on the same side, so you get 2x plus 5. We're going to end up with a fraction here. Don't be afraid of fractions. They're okay. I only like a fraction of you. Just kidding. All right, subtract 5 from both sides, and we get 2x is less than 3. And so I get x is less than 3/2. Who got that? Anybody? Yes. Note on the video, like all of them got that. Okay, here we go. And then we're going to go ahead and go to our number line. Did you forget to graph it? What did I do?
On that one, did
Yes.
you not switch the symbol? Or
You don't, because I divided it by a positive 2.
Okay,
And
so
so,
you do it by
negative, exactly. Ooh, good question. All right, so go to 3/2, which is, here's 0, 1, 2. 3/2 is 1.5. Open circle. Don't forget, we're not including 3/2. It's x is less than, we're going to the left. As Beyonce would say, to the left, to the left. All right. Yeah.
So only when we're dividing by like a negative 2?
Mhm. Exactly. Now, let's talk about that real quick. So if I had negative 2x is greater than 10, and I divide by a negative 2, I would need to flip the sign, okay, for sure. Because this is what we're doing. We're dividing by negative 2. This is the important part. Some people, they'll just start flipping the sign because they like to, but they're wrong. So if you had 2x is greater than negative 10, and they see that negative there, and they're like, ooh, I got to flip the sign. No, no, no. You got to look at this, what the operation is. I'm dividing both sides by positive 2. Has nothing to do with flipping a sign. Okay? Yeah?
So when you're graphing on the number line, because on that last example, I just put the 3/2 in the middle.
I'm fine with that. Yep. Did you guys hear that? He put 3/2. He just went like this and went 3/2. That's fine. Open circle that way. Great. No problem. All right. I know that you know that I know that you know where 3/2 is on a number line. Now, there's going to be some special cases, so let's talk about those. Number 4. You remember when we did equations and we solved them? They look like normal equations, but then they turned out to be no solution or all real numbers. Well, that's going to happen with inequalities too. All right, so let's say we have negative 2 times 3x plus 1 is greater than negative 6x plus 7. And we're going to say they asked us to solve this. And you don't know, you can't tell just by looking at them that it's going to turn out to be a special case or one of the weird problems. It looks just like a normal, regular inequality. Kind of like people. You walk up to them, you think they're going to be interesting and not normal, but they turn out to be weird wackos. Okay, so go ahead and distribute. It's true. And you get negative 6x minus 2 is greater than negative 6x plus 7. Okay, so still go about your business like you're doing a normal, regular problem. Get your x's together. So you want to add 6x to the other side. Add 6x. And what happens is you get a negative 6x and a 6x eliminate each other. They cancel each other out. And so you get a statement. You get negative 2 is greater than 7. What? Negative 2 is not greater than 7. They're crazy. Well, they're not crazy. You know what happens here? There's no solution. There's nothing that you can plug in for x that's ever going to make this statement true. And so you would either write, I don't mind if you write never. You could write a circle with a line through it telling me no solution. You could actually write the words no solution. Okay? But don't just leave it as negative 2 is greater than 7. I need you to go one little step further and tell me, nope. Okay? Something that makes me know that you know it's never, no solution. All right, let's try number 5. So you're probably guessing what I'm going to do next. You're probably right. So we just did a no solution or a never. Let's do an always. Let's see what that looks like. 5 times 2x minus 3 minus 7x is less than or equal to 3x plus 8. Okay, we're going to get a true statement here because I already told you what the answer is. I'm sorry, spoiler alert. But like they said again, you don't know what the problem is. You don't know it's going to be different. It looks regular. It looks like a normal, everyday problem. Distribute. You're probably getting really good at solving by now. And then combine your like terms on one side. We have a negative 15. No, we have a 10x minus 7x is 3x minus 15. Okay? And then you can see right here that the 3x's are going to cancel out because you got 3x on one side, 3x on the other side. And you get that negative 15 is less than or equal to 8. That's true. It's true. It's always true. And so what you can say is you can say all real numbers is your answer. Any real number you want to plug in there is going to work. Or you could also say always true. I don't mind that at all. But make sure you say something about it. Okay? All right, we're going to take a little pause here. Last part C. So now we're going to do some compounds. We're going to do some compound inequalities. So these are the ones that we talked about at the beginning of the lesson today about and or. Okay? And it's kind of like doing 2 problems in one. So that's kind of a bummer. All right, so here we go. Let's do the next one. We're on number 6. Number 6. So let's say I tell you that you need to solve and graph something that has an and in it, which means it's going to be true for both statements, okay? So if I have 7 is less than 2x plus 1 and 3x is less than or equal to 18. So I'm trying to find numbers that will fit both of these inequalities. Okay, so my solution is going to be the ones that work for both. Not or, it's not, oh, it could be that one or that one, but and. So let's do it. So what you're going to do is you're just going to solve them separately. So go over to this one, and we're going to subtract 1. You get 6 is less than 2x. And then divide by 2. And so 3 is less than x. A lot of people don't like that written like that. If you're okay with it, that's fine. It's not wrong. But most people prefer to rewrite it as x is greater than 3. It's the same thing. Okay? So you can either leave it or rewrite it so the variable's first. All right, so then and is going to drop down. Divide by 3. X is less than or equal to 6. That's an and problem right there. Now there's 2 things you can do. You can either leave it like that, or you can combine it into one compound inequality. I do not mind either way. What I mean by that is this. See, x is greater than 3, so I can write that as 3 is less than x is less than or equal to 6. I can write it as one thing, or I can just keep it separate and just put an and in the middle. Now let me show you how to graph this. So we have 3 and 6. So I have x is greater than 3, open circle at 3 going to the right, and x is less than or equal to 6. So close that circle on 6, include 6, and numbers less than or equal to 6 go this way, and so what we get is everything in the middle. Okay? So if I told you guys, hey, pick a number greater than 3 and less than or equal to 6, anything in here would work. 6 would work. Pi would work. Pi is always a fun one to pick. Pick a number between 1 and 10. Pi. What? All right. Number 7. So let's suppose that it was already all connected into one thing. It's one whole problem and it looks like this. -2 is less than or equal to 2x minus 4 is less than or equal to 12. Okay. This looks like one problem. There's kind of two problems in here. This stuff in the middle is between -2 and 12. And I have to find out what x is between. This has all the stuff around it. I want just x by itself. So what I'm going to do for this one is we're going to add 4 to everybody. Okay? Because we have symbols here and here, so you need to do it on all the different sides. I know it feels kind of weird, but it's true. And so what you get is you'll get 2 is less than or equal to, when you added the 4, the -4 and the 4 go away, they make 0, equals 2x is less than 16. Okay, so we're still solving for x in the middle. It's not by itself quite yet. We're going to divide everybody, all the 3 parts, there's 3 parts here, by 2. So I get 1 is less than or equal to x is less than or equal to 8. And don't forget to graph your answer. Okay, as if it says to graph it, if it doesn't, you don't need to. So here's 1, here's 8, and it includes 1, it includes 8, they're both or equal to, and then all the stuff in the middle. Any questions on that one? You've done that before, yeah. Yes, that is a great question. Suppose that this was a -2 in here. Then yes, when you're dividing by a -2, you would need to flip both of the signs the other way. Good call. Love it. All right, let's do an OR problem now. Number 8. Here's an OR problem. Suppose we want to solve this. 4x minus 2 is greater than 14. 4x minus 2 is greater than 14. Or 3x minus 4 is less than or equal to -13. All right, I want you to solve those. If you're doing these with us, solve those. All right, add 2. Yeah, you can do a lot of this in your head. Divide by 4, so x is greater than 4. Over here, add 4. Divide by +3. We're not dividing by a negative number. We're dividing by a +3, so you're not going to flip the sign here. You get x is less than or equal to -3. Put an or in the middle. Never combine ors, because you're this or that. You don't want to combine them into one long string. And then to graph this, you just graph them separately. And put 0 right smack dab in the middle. And if I say x is greater than 4, that's an open circle at 4, and we go greater than. X is less than or equal to -3. It's a solid dot over here. So most of the times, the ands are going to come together, the ors are going to go apart. Yeah?
So what's that, like, I still don't understand the point of the ors. Like, why can't they just be 2 separate problems?
Well, because it's one problem, but there's more than that answer. So if I say, give me a number that's less than -3 or greater than 4, that opens it up to even more answers. It's just a different problem than if you just had that, or if you just had that side. This is together. Both of these answers are true for this problem. It's not separate. You do them separately, but then the answer comes together as either one will work. All right, let's do a word problem now. No. Yes, word problem. All right, it says here that the lengths of the sides of a triangle. So the sides of a triangle are in a ratio of 3 to 4 to 5. 3 to 4 to 5. It's a ratio. I'll explain what that means in just a minute. And it says here that describe the length of the shortest side if the perimeter is not more than 42. So the perimeter is not more, perimeter is not more than 72. Okay, here we go. This is just like what the problems that we did the other day. I think that was on Monday. We did word problems with equations. It's the same idea. So if we have a triangle that is set up as a ratio of 3 to 4 to 5, yeah?
It's supposed to say ratio, not rate.
Ration. Yeah, ratio. Oopsies. Thanks. Where's the eraser? There it is. I don't use that very often because I rarely make mistakes. I'm just kidding. I make them all the time. It's not working. Hold on. Let's try that. Oh, there we go. Thank you. Ratio. All right, 3 to 4 to 5, perimeter is not more than 72. Okay, so here's how we represent this. If it's a ratio, then it's going to be 3x, 4x, 5x. 3 to 4 to 5. If you reduce, all of those x's will reduce out. If it was 10, it'd be 30, 40, 50, stuff like that. So now we're going to add them up because it's perimeter. So we get 12x, and the perimeter is not more than 72. That's a really weird way to say that, huh? So it's not more than 72, so it's going to be less than 72. It's like a double negative, huh? Not more than, yeah. And then go ahead and divide by 12. So x would be less than, what does it turn out to be? 6? X is less than. Not more than 72. That could be equal to 72 though, right? Yeah, let's say or equal to. Okay, so let's describe the smallest side. The smallest side, if you were to find the smallest side, it's this 3x right here, then that would be 18. Okay? So the smallest side is not going to be any more than 18. So the smallest side is going to be 18 or less. 18 or less. There you go. It's going to be 6 times 3. And so the biggest one would be 6 times 5, 6 times 4. There you go. All right, let's do one last thing. I have to just mention this. Some special cases real quick. Special cases. Now, what if you get something that says x is greater than 5 and x is less than 2? Okay? And even if you try to graph this, x is greater than 5 over here, and x is less than 2. This right here does not make sense, the word and. If I ask you on the next test or quiz, hey, pick a number greater than 5 and less than 2, and then I don't pass you, I fail you all because, you can't do it. There is no number greater than 5 and less than 2. Nothing. And so this would be no solution if you get something like that, something that doesn't work. What happens if it says x is less than 5 or x is greater than 2? Now, the word or here means one or the other is possible, can work. So if I were to graph this and show you all the numbers that work for this, well, take this side. X is less than 5. All of these numbers are less than 5. Okay? Or x is greater than 2. All of these numbers are greater than 2. And do you see what I did? I went past. Because it's not about the overlap, it's about being or. If I tell you pick a number greater than 5 or less than 2, any single number would work. And so this answer would be all real numbers. So those are special cases that happen sometimes. You'll solve, it'll look normal, and you'll get something like this, and it'll be kind of strange. Okay? That's it.